This is kind of an internal video showing one of the problems that I'm trying to track down with the FujiNet network device code. Particularly that we're having a series of memory leaks that are happening as part of opening and closing and using the network device, and finding that, with each of these cycles, we're losing somewhere in the range of about half a kilobyte worth of bytes each time, and this is coming from the low heap. So by the time you do say maybe a few dozen of these operations, you'll find that you run out of the 320K of active memory that's currently on the ESP32 that's not part of PSRAM. That's a different thing entirely. While the FujiNet does have 4 megabytes of PSRAM, certain things don't have access to it or are not designed to use it. So, anyway, regardless of which this leak is happening, it needs to be fixed. So, in order to show what's going on here, I've kind of put together a debug window on the left coming in from VS Code, and capture from my Atari on the right. Now, when you first start up FujiNet here, the first thing I do is look at the amount of low internal memory that's available once we immediately start up. You'll see that we have 4 megabytes of starting heap right here, 4.3 or so. Okay, fine. But you'll find that in actuality, almost immediately after starting the process, the 320K memory that we have left, we have a little less than 200K left just to start. And then we go through the process of, setting up the device, making sure the flash is initialized, the FAT driver is initialized, and as a consequence to all of this, by the time that you get down to the end here, okay, setup is complete. The device can boot at this point, and we're down to 165K of low memory at this point. However, the Wi-Fi stack needs to start. The Wi-Fi stack needs to configure itself, and the web server also needs to start, and it also needs to configure itself. So by the time you actually get down here, you wind up, it's not shown here, but you wind up with about 66 kilobytes of memory available in the low end. So we'll go ahead and boot. I've rebooted this machine, so it's going to go into config. I turned off all the high speed and PBI and all of that stuff here too as well. But let's just, for example, boot into the lobby as an example here. We'll go ahead and lobby, sure, we'll boot into the lobby. And you'll see almost pretty much immediately here, we go in, we do an HTTP call. Once we get down here, hold on a second. Yep, all right. My scroll back is extremely large, so it takes a second here. Let me see. We do our little HTTP call and everything, and we find our free low heap. At the end of this call, by the time we get into the destructor, is 53K. Well, we check down here a little bit. The destructor has already been called on the HTTP client, and it returns about 3K worth of memory right there. But then we have the protocol delete that's part of SIO close, and that by that point we hit 56, and then we do a protocol delete here, and all of the bits and pieces that the network adapter was holding around as part of the protocol come back, and we're up to 64K. Well, you think, okay, that's a good thing here. We're obviously returning stuff back to the system. This is good, but watch what happens when I take and do the refresh again. Keep track of that number right there, 64,567. That number is now 64,315. 64,557. 64,315. That's 252 bytes just gone. It's there. It's gone. It's not coming back. Do it again. And now it's 64,063. So again, 64,063. Do it again. 63,811. Do it again. 63,559. Do it again. 63,307. And so on. This is with a complete open status read, do stuff, close cycle. And this is, parsing JSON, etc. And you'll see that this number is going down rather consistently. If we go into a particular game, we'll see that basically the same thing finds itself asserting here as well. We come in, got some app key stuff going on here, some parsing, reading, 58,147. $57,795. 57,447. We're losing a couple hundred bytes up to more than half a K each time that we're doing something. 56,751. 56,403. 56,055, and so on. And eventually what will happen is that this number will get down into the 2 kilobyte range or so, and the HTTP client will not have enough memory to do a DMA buffer, and the requests will simply start failing. So you can see that this is happening. We'll go ahead and escape out here. We'll quit the table, come back out. 53,619. 53,359. And so on. So now if I quit, boom, there's an interesting little thing that seems to happen there. I hit reset in the middle of all this, so something goofy kind of happened here. Let's see what happened. My scroll back is now absolutely huge. And we have some heap poisoning that seems to have happened. It might be the result of my heap testing, but we shall see. It's part of the unmount again. Pulling that down, pulling that away. That particular bug has reared its ugly head again. This is not good. Okay, let me just reset. Now for the next part of this, I will actually take, and we will go into something else entirely. And, sorry, wrong server. And we'll go into NOS. I need to put NOS 5.0 up on the file server. I'll do that today. But this is the same situation in NOS 0.4.3 as well, so whatever. It's the same fundamental issue. So here we go. Did my auto exec load here? No, it didn't. Okay. So let's go ahead and use a different protocol adapter entirely. TNFS TMA2. And we will simply do a directory. Okay, so 61,063 you'll see that we got some of this potentially. Well, no, it's my protocol, my adapter rebooted. So yeah, because I hit reset. So there we go. 61063, 6819. And this is like doing a directory. Same thing happens if we do other things as well. For example, let's go ahead and just there's Congo Bongo. I'm going to hit the reset here. Come back in. And we'll find 59, 427, etc., etc., etc. And we'll find at each one of these we're losing memory at every potential operation here. So I'm like, yeah, I'm at a loss. Is there something that has just an execute? I'm wondering, do I have something here that doesn't hang itself at initialization? Let's see if okay, so it doesn't, NOS isn't closing itself off here. So I have no way of knowing what my, without basically putting a status heap here. Now, in order for me to do this, what I'll actually, let me see what happens if I can take, for example, and do one at every status here. To do what I'm doing here as part of my testing process, I am using the heap testing capabilities that are built in to every single, to the ESPI ADF. And in order for that to work, I am basically, see if I can do this. We have HTTP. How do I want to do this? I'll do it in the network device itself. Status. SIO network status. SIO status. SIO status and SIO status local. Status local, status channel. We move that down so we can see what I'm actually going to do here. Pick a particular IO operation here, and I'm just gonna take and drop I'm not even gonna do a heap trace here. I'm just gonna drop a memory. Get free internal heap size. And we're gonna see what that looks like here. So let's take that, we'll go ahead and upload and monitor. Let's see how this works in practice. And while that's happening, I will, since this is in CC65, I think if I hit reset here, my display is gonna go nuts. Oh no. Yeah, okay. Sounds about right. Turn off, turn back on. Yeah, who cares? And we'll see how this works in practice here. Let's just upload this. There's also the heap tester that I've been using, and while it's informative, I think it has the potential to give off misleading results, like every other piece of testing equipment I've ever used. Okay. Let it reset itself. Come on. Take your time. The device is already initialized. I'm waiting for Python to make up its mind and start the monitor. Okay, there we go. So if I now we see that that's happening here. SAO status. See, status. Now, if I take, and let's see if this happens as part of loading something into memory. Let's see, what am I going to load into memory here? What XEXs do I have? Bongo, yeah, good old Congo Bongo, why not? You'll notice that here, with the I/O operations themselves, the low heap is not decreasing, and the TNFS adapter and is actually increasing here as things get tidied up. But the number will keep going down. So if I take that down again. That is interesting. It booted back into... Yeah, that's very troubling. But it didn't... Okay. Go figure. So 62007... 59455. At the end of each status turn. $59,987, so something gets reclaimed back. And we do the close. Okay, so the close happens and that number comes back up to 61K. And that makes sense to a certain degree here. So let's use this as a circle back around here. Let's take, and for example, use a different protocol adapter. Low heap 51863. Whoa! That's an interesting failure mode. $28. Whoa! And this thing's leaking like a son of a bitch. That's interesting. It's trying... Yeah, there's definitely something going on in the HTTP adapter here. And we're about to fail. Bam. Okay. Well, that's certainly interesting. So we have the... Yeah, it was trying to grab the auto exec because one's defined. Oopsie. That's interesting, to say the least. Yeah, this video gets more interesting the more I let it go. So definitely some bigger issues in the HTTP adapter and some smaller issues in the core networking code itself. So let me get rid of that auto. Sorry, help us. Can I not delete the auto run? Set the batch file. So I guess, yeah, it's just That's an interesting little failure mode. So, okay. $52,895. But since I didn't set the prefix this time, 52,895. Yeah, that shouldn't happen again. Okay. $52,483. One more time. So again, that's more like half a kilobyte there. $52,079 there as far as that's concerned. But we're going to get some of that back by the time it finishes. Oh no. Ooh, we lost a big chunk there. No, 52,495. No, that's right. Yeah. You can see the perform subtask exiting. That's the HTTP network stack basically finishing itself up right there. And I'm kind of curious, can I type all? No, I can't. I'm not going to press my luck typing in an FTP location. Anyway, so you can kind of see the scope of what's happening here. This one's going to take some time to track down, but it has to be tracked down because it's literally just death by 1,000 cuts, and this is unacceptable. It's got to be fixed. So I'm going to take and continue to chew on this and to try and find where this is happening. For anybody who wants to help, of course, they can grab the firmware. And look at the ESP heap tracing page on ESP-IDF, and it shows you how to use the heap tracer. There's already a hook for it in place, and I have a particular branch that I'm working out of called Find Memory Leaks, which already has the heap tracer enabled, so you can basically take and attach heap start, heap stop, and basically see where potential memory leaks are happening and whatnot. So with that, I'm going to basically end the video here. But I wanted to show kind of some of the things that I'm running up against and things that this needs to be dealt with. So with that, thanks guys for watching, and see you on the flip side.